Hello everyone, this is Poonam. Today this is the 8th part of chapter Electricity for class 10th, and today's topic is the resistances in parallel. In the earlier video we have done the resistances in series, or we can say the combination of resistances which are of two types, and first we have done resistances in series. Today this is the resistances in parallel. The reciprocal of the combined resistance of a number of resistances connected in parallel is equal to the sum of the reciprocals of all the individual resistances. This is the reciprocal of the combined resistance, and these are a number of resistances which are in reciprocal form, and their sum total is equal to the reciprocal of the combined resistance. The combined resistance is less than the smallest individual resistance. What does it mean? It means that suppose we have the three resistors, one of 2 ohm, then 6 ohm, then 18 ohm. So the combined resistance in case of the parallel combination will be less than the smallest resistance. Smallest resistance is 2 ohm. So the answer will be less than 2. You can calculate it by using the formula, that is 1 by 2 plus 1 by 8 plus 1 by 16. The LCM will be 16. 2 8 are 16, 8 2 are 16, 16 1 are 16, 8 plus 2 10, and 1 11 upon 16. This is equal to 1 by R. So if we need to calculate the R, so R will be 16 upon 11. 11 ones are 11, the remainder will be 5, 11 fours are 44. So the answer will be 1.4 ohm, which is less than 2 ohm. So this point means that the combined resistance, means the resultant resistance in parallel combination, will be less than the smallest individual resistance. The next point is the potential difference across each resistance is same and equal to the voltage of the battery. In case of series we have done the potential difference is different, but in this case the potential difference will be similar for all the resistances. Suppose this will be the diagram. These are the three resistors R1, R2 and R3, and this is the battery. Suppose it is giving the 2 volts current. So this 2 volt potential difference is for R1, R2, R3. It is for the it is same for all these three resistors. The next point is different amounts of current flow through each resistance. The current is flowing like this from positive terminal to the negative terminal. So the current is flowing in this way. Now from this point, this current is flowing in three directions. This current is I1, this is I2, and this is I3. So different amounts of current is flowing through each resistance according to their needs, according to their power, but the total current will be, this total current I will be equal to I plus I1 plus I2 plus I3. The sum of the currents flowing through all the resistances is equal to the total current, means I is equal to I1 plus I2 plus I3. Now this is the derivation for the combined resistance of the three resistances connected in parallel. For this derivation we need to draw this diagram, and the three resistors R1, R2, R3, they are connected in parallel along with the battery and a key. Now according to this diagram, the current is flowing from positive terminal to the negative terminal, and the current from this point is flowing in the three directions I1, I2, I3. After completing these resistances, flowing through these resistances, again this I will be similar. That means the sum total of the three. Now how can we derive this formula? We have three resistors R1, R2 and R3, and the currents I1, I2, I3 are flowing through them, and the total current I is equal to I1 plus I2 plus I3. This is equation number 1. Now according to Ohm's law, the current I, total current, will be equal to V upon R, and I1 is equal to V upon R1, because the potential difference is similar, but the resistance and the current will be different for different resistances. So I1 is equal to V upon R1, I2 is equal to V upon R2, and I3 is equal to V upon R3. These are equation number 2, 3, 4 and 5. Now putting the values of I, I1, I2 and I3 in this equation number 1. In place of this I, we are using V upon R. In place of I1, we are using V upon R1, I2 V upon R2 and I3 V upon R3. After putting the values, we get this type of equation. Now in this equation, we can observe that this V is common. So we will keep this V outside the bracket. This V 1 by R is equal to V. This V is in this form, means the upper form. So this V, and we get 1 upon R1 plus 1 upon R2 plus 1 upon R3. V and V will be cancelled out. We get 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the derivation for the resistances, three resistances combined in parallel. Suppose you have given for the two resistances, so you will derive till here only, means I1 and I2 only, no need to write for the I3. But if you will need to combine the four resistances, then you will add I4 also. I4 is equal to V upon R4, and you will add here. So in this way you can derive the equation. Now this is the question. Calculate the equivalent resistance when two resistances of 3 ohm and 6 ohm are connected in parallel. We have two resistances, that is R1 which is equal to 3 ohm and R2 which is equal to 6 ohm, and these two resistances are connected in parallel like this. This is 3 ohm resistance and this is 6 ohm resistance, and we need to find out the equivalent resistance, that is 1 upon R is equal to 1 by R1 plus 1 by R2. This is 1 by 3 plus 1 by 6. LCM, it will be 6. 3 2s are 6, 6 1s are 6. We get 3 upon 6, and this 1 by R is equal to 3 upon 6, or we can say 1 by 2. Take the reciprocal. This R will be equal to 2 ohm. So the equivalent resistance of these two resistances, 3 ohm and 6 ohm, which are connected in parallel, will be less than 3, that is equal to 2 ohm. So this is the numerical related to the parallel combination. In the next video we will discuss some more numericals.